ठीक है, लेट्स फर्स्ट कंप्लीट डाउट्स ऑफ पीरियोडिक टेबल। कितना सॉल्व कर लिया तुम लोगों ने? डाउट्स इन पीरियोडिक टेबल बुकलेट, डन ऑल, वेरी गुड, वेरी। Do you have any doubts in the periodic table booklet? You have doubts in get equipped with JEE mains. Okay. Anyone else has any doubts in periodic table? और कितने लोगों ने सोल्व किया है? अंश, सार्थक, आन्या, अवंती, हैव यू सॉल्व्ड इट? पीरियोडिक टेबल कितना सॉल्व किया है? FBO 45 में डाउट है। Get equipped with JEE main, question number 8 and question number 19. Let us first discuss FBO question number 45. FBO question number 45 ये तो क्लास में कराया हुआ एग्जाम्पल है वीडियो। Oxygen, sulfur, selenium. The order of electron affinity expected is to decrease from top to bottom, except in the second period has lower electron affinity than third period. In the group 16, oxygen is found to have the least electron affinity. Order is sulfur, selenium, tellurium, और last में oxygen आता है. So given options में से sulfur greater than selenium greater than oxygen आएगा. So D option. 45 is the B. Clear है? Europe, question number 45. My voice is muffled, so let me check. Let Is it better or still the same? Mm. One second. My side, everything settings has been fine. I don't know geometry. There may be some network issues. Okay, so let us continue like this maybe. Because from my side, settings etc. is all fine. Okay. Next, we'll do question number 8 of getting to JEE main. With respect to oxygen family, sorry, with respect to oxygen, मतलब when bonded to oxygen. Statement का मतलब हुआ when bonded to oxygen. When bonded to oxygen, maximum valency is shown by which element? Valency can be often related to the number of valence electrons. More is the number of valence electrons, more will be the valency. Valency can be related to the maximum valency is often equal to number of valence electrons. Number of valence electrons, number of outermost electrons is maximum for halogen family. Halogen have 7 valence electrons. इसका आंसर आ जाएगा halogen family. Maximum valency with respect to oxygen is shown by halogen family. An example is Cl2O7. If you look at the structure, chlorine is bonded to oxygen by 7 bonds. There are 3 double bonds and 1 single bond.
क्लियर है ये? Is it better now? Sound? Okay, fine. Next out is get equipped to JEE main question number 19. Next, let us discuss question number 19. Which of the following metal is expected to have the highest third ionization enthalpy? We have to compare the IE3 values. To compare the IE3 values, we'll write the electronic configurations of the divalent ions. We'll write the configuration of chromium 2 plus, manganese 2 plus, vanadium 2 plus, and Fe2 plus. These are the metal ions. We'll write the configurations. Man2 plus will be D5, this will be D4, this will be D3, and this will be D6. From left to right, ionization energy will increase, but manganese will have higher ionization energy than Fe because of stable half-filled subshell. So IE3 का order आ जाएगा vanadium less than chromium less than Fe less than Na. ठीक है? एक सेकेंड रुकना, समझा? अभी ठीक है नेटवर्क को। नेक्स्ट कौन सा क्वेश्चन नंबर 19। तो 19 समझा क्या? विरोक, क्वेश्चन नंबर 19 समझा क्या? ठीक है। अभी नेक्स्ट डाउट इज विंडो टू जे एडवांस क्वेश्चन नंबर 13। विंडो टू जे मेन या विंडो टू जे एडवांस? अच्छा मेन, विंडो टू जे मेन क्वेश्चन नंबर 13। ओके। इसमें कुछ कंसेप्ट से जो मैंने नहीं कराया वो करा देता हूँ मैं। एक तो कंसेप्ट है रिगार्डिंग इनर्ट पेयर इफेक्ट एंड अनदर इज रिगार्डिंग एसिडिक स्ट्रेंथ ऑफ हाइड्राइड्स। ठीक है, ये करा देता हूँ मैं, उसके बाद ये हो जाएगा। ठीक है, इनर्ट पेयर इफेक्ट इज इन की ब्लॉक, बट उससे एक क्वेश्चन है तो चलो मैं डिस्कशन में ही बता देता हूँ। ये inert pair effect. The 13th question, the first part is based on inert pair effect. Okay, what is inert pair effect? Periodic doubts में we will talk about inert shell effect. Inert shell effect. For p block elements, as we go down the group, the outermost electrons, the outermost s electrons become less and less reactive. And for the 6th period elements, the 6s electrons become almost inert. This is called inert shell effect. Talking about group 13 elements. Group 13 elements: boron, aluminium, gallium, indium, thallium. Configuration for the valence shell is ns2np1. Normally, all the 3 electrons take part in bonding. The common oxidation number shown by these elements is +3. But as you go down the group, they also show an oxidation state of +1. +1 where only the p electron takes part in bonding. Only the p electron is involved in bonding. If only the p electron is involved in bonding, we'll get a charge of +1, oxidation state of +1. If both the p electrons and s electrons take part in bonding, then we'll get a charge of +3. Okay. So it is observed that boron and aluminium show oxidation state of +3 only. Gallium, indium show +3 and +1. Okay. Stability of the lower oxidation state decreases down the road. Decreases down the road. Sorry, stability of higher oxidation state decreases down the road. यहाँ पे लिखेंगे stability of +3 order. Boron, aluminium, gallium, indium, gallium. Stability of +1 का reverse order. Stability of lower oxidation state increases downward. लिख लो ये points. Stability of the higher oxidation state decreases and stability of the lower oxidation state increases downward. Run करूं? एक सेकंड वीरो. बोलो वीरो.
Yes, sir. Sir, in the middle you have written oxidation number of +3 and oxidation number of +1. Only p electrons involved in the bonding. Sir, can you explain this?
देख. All these elements have 3 valence electrons.
Yes.
Yeah? 2 valence electrons in the s subshell and 1 in the p subshell.
Yes, sir.
If only the p electron takes part in bonding, it will show a charge of +1. If the p electron as well as the s electron take part in
10
bonding,
plus.
it will show a charge of +3. So there are two oxidation numbers that are shown by group 13 elements that are +3 and +1. Okay. Boron and aluminum show +3 only, they do not show +1. Gallium, indium, thallium show +1 also. The tendency to show the lower oxidation number increases down the group, because as we go down the group, less electron becomes more and more inert.
Yes, sir. Okay.
Okay. Stability of lower oxidation state increases down the group. That is, if you write the order of stability of +1, boron, aluminum, gallium, indium, and thallium. आ रहा समझ में? Same is true for group 14 and 15 also. ग्रुप 14 में देखेंगे, ग्रुप 14 the elements are carbon, silicon, germanium, tin and lead. The configuration is NS2 and P2. Oxidation numbers are +2 and +4. Okay. It is found that up to the first 4 elements, stability of +4 is greater than +2, but for the last element, stability of +2 is greater than +4. The last element के lower oxidation state becomes more stable. The outermost s electrons become inert. This shows that Pb +4 gets easily reduced to Pb +2 because Pb +2 is more stable. Therefore, Pb +4 is a stronger oxidizing agent. We can compare the oxidizing powers. Oxidizing power will decrease down the group. So they will increase down the group. Pb +4 is a stronger oxidizing agent. So there is CO2, SiO2, PeO2, SNO2, PbO2. So +4, +4, +4. Stability of +4 कम होगा, so tendency of reduction will increase. It will behave as a stronger oxidizing agent. ठीक है? तो 13th का ए ऑप्शन समझा? Now 13th का बी और सी will discuss acidic strength in hydrides. Hydrides are compounds with hydrogen. इसमें है from left to right in period. As electronegativity increases, acidic strength increases. Example, comparing acidic strength between CH4 and H3 to HF. So HF is a stronger acid than H2, is a stronger acid than NH3, is a stronger acid than CH4. और एक और point है, from top to bottom in group, As size increases, acidic strength increases. The order is HI greater than HBr greater than HCl greater than HS. Reverse order will be for basic strength of hydrides. आगे समझ में बी और सी ऑप्शन विरोध 13th का बी और सी ऑप्शन Any other doubt? Okay. So let us start with chemical bonding. Give me a minute. Narendra does not have periodic table. Periodic table chemical bonding are given as chapters of inorganic chemistry. Inorganic chemistry के लिए you can buy book of weakage as well. Okay. Okay, give me a minute. We'll start with chemical bonding. Chemical bonding 1. Why do atoms form bond? Why atoms combine to form bond? ये reason है. What is the cause of bond formation? Okay. Atoms are not stable as it is. In isolated form, atoms are not stable. They are generally stable in the combined form only. Atoms are not stable in their isolated states. In their uncombined form. They combine with other atoms to gain stability by decreasing their potential energy. They combine with other atoms to gain stability by decreasing their potential energy. This is the cause of bond formation. When atoms do combine, when atoms come close to each other, suppose this is the distance between atoms and this is the potential energy. Y-axis potential energy plot कर रहे हैं, x-axis distance plot कर रहे हैं. At very large distance, there is no interaction between atoms. Potential energy is almost zero. At a particular instant, potential energy becomes minimum, and then if you bring the two atoms further closer, potential energy will increase. Okay. यहाँ पे कुछ important points हैं. The point where the potential energy is minimum, the most stable state is called as the bonded state. The distance between the nucleus and the point where bond energy is minimum, where potential energy is minimum, is called as the bond energy. The E stands for bond energy. Actually, this is bond length, sorry. बॉन्ड एनर्जी ये वाला वैल्यू हो जाएगा. Bond energy, the energy required to break a bond. So initially, when atoms are separated by a large distance, potential energy is almost zero. When the atoms come closer, the potential energy decreases. The point where potential energy is minimum is the bonded state, at which the distance between the atoms will be called as the bond length, and the difference between energies at are equal to infinity and the bonded state is called the bond energy. Okay, clear है ये diagram? Atoms do combine to form molecules to form bonds to attain stability by decreasing potential energy. ठीक है, ये नोट कर लो जल्दी से. So atoms combine to form bonds to attain stability, and they attain stability by decreasing their potential energy. K. Kumar is a good book. Inorganic chemistry के लिए K. Kumar भी कर सकते हैं. Either V.K. Jaiswal or K. Kumar. Mainly chemical bond can be of three types. We will discuss types of chemical bond. Types of chemical bond. Broadly speaking, chemical bonds can be classified as ionic bond, covalent bond, and metallic bond. Ionic bond is also known as electrovalent bond. Coordinate bond is a covalent bond. So there are three types of chemical bond: ionic bond, covalent bond, and metallic bond. Let us discuss briefly what is the difference. Please stand करो. इसमें first we'll talk about ionic bond. It's formed between a metal and a non-metal. Or you can say that formed between atoms which have a large difference in their electronegativity. ठीक है. Examples of molecules or substances having ionic bond: NaCl, KCl, NaBr, Na2O, MgO, etc. Covalent bond is formed between two non-metals. Or we can say that it is formed between high electronegativity. Examples are Cl2, Br2, BrCl, HCl, etc. Covalent bond is formed between two non-metals. Metallic bond is between two metal atoms. It is the attraction between metal atoms. Between different metal atoms in a solid. Metal atoms in a metallic solid such in a pure metal or an alloy. In a solid metal or alloys. In a solid metal or an alloy. So solid metals में और alloys में metal atoms के बीच का जो attraction force है bond बोलते हैं. Is electronegativity. Will result in formation of a covalent bond. Two atoms of low electronegativities, metallic bond, and atoms of different electronegativities will form ionic bond. Clear है ये? Turn करूँ page turn करूँ. We first study ionic bond and its characteristics before coming to covalent bond. ठीक है. The basic characteristic of ionic bond, a basic criteria or basic scheme of formation of an ionic bond is there is a metal, there is a non-metal. Metal atom loses electrons and non-metal atom gains electrons. So effectively, there is a transfer of electrons from a metal to a non-metal. During this transfer of electron, metal forms cations, non-metal forms anions. The cations and anions attract each other via ionic bond, electrostatic force of attraction to form ionic bond or ionic compounds. Okay, so we can say that ionic bond is formed by transfer of electrons from Ionic bond is formed by transfer of electrons from metal to non-metal. Ionic bond is formed by transfer of electrons from metals to non-metals. Metal form cations, non-metals form anions. Metals form cations and non-metals form anions. The cations and anions attract each other to form a three-dimensional network of ions, which is often called as a lattice, known as a lattice. For example, देखो sodium atom loses electrons to form Na plus. Chlorine atom gains electrons to form chloride ions. The Na plus and Cl minus ions attract each other to form a lattice. So, ionic bond में we do not have a single molecule. Okay, there is a network of cations and anions. There is a network of cations and anions. तो हमको कैसे represent कर सकते हैं? There are Na plus ions surrounded by, एक second. Na plus ions surrounded by Cl minus ions, Cl minus ions surrounded by Na plus ions. ऐसा एक नेटवर्क बन जाता है. We do not have a single molecule of NaCl, rather we have a network of cations and anions, and such networks are called as lattice. Actually, मैंने ये 2D representation बनाया है. It is actually a three-dimensional network. यहाँ पे देखो 2D में देखेंगे each sodium is surrounded by 4 chloride ions, but actually में 3 dimension में एक chloride ऊपर और एक chloride नीचे भी है. Effectively each sodium is surrounded by 6 chloride ions, and each chloride is surrounded by 6 sodium ions. Often ionic compounds contain a lattice of ions. What is a lattice? Lattice is a network of particles. Okay. In case of ionic compound, the lattice will consist of a network of cations and anions, in which a cation will be surrounded by some anions, and anion will also be surrounded by a certain number of cations. Okay. आ रहा है समझ में? We will write this point. In a lattice, in an ionic lattice, the cation and anions are surrounded by a definite number of oppositely charged ions. In an ionic lattice, the cations and anions are surrounded by a definite number of oppositely charged ions. This is often known as the coordination number. Abbreviated as CN. In the NaCl lattice, coordination number of Na plus is 6. Coordination number of Cl minus is 6. दोनों की coordination number 6. You say that coordination number of NaCl is 6:6. Next, we'll study about lattice energy. or lattice enthalpy. It is the energy required to break a lattice, 1 mole of a lattice, into its gaseous ions, So whenever lattice is broken into its gaseous ions, some energy is required for this process. Energy required is called as lattice energy. An example we can write: when NaCl solid is broken into Na plus gaseous and Cl minus gaseous, some energy will be absorbed for this process. The delta H will have a positive value. The energy absorbed is called as the lattice energy. We'll say the delta H Le will have a positive value. Another definition for lattice energy is in terms of formation of lattice. We can define lattice energy also as it is the energy released when 1 mole of a lattice is formed from gaseous ions. It is also defined as the energy released when 1 mole of a lattice is formed from gaseous ions. विरोध क्या बोल रहा है? What can be reduced further? What are you talking about, विरोध? नहीं, हम अपनी मर्जी से कुछ reduce नहीं करते. ये ratio कोऑर्डिनेशन नंबर में हम ऐसे रेशियो स्पेसिफाई नहीं करते, लेकिन रेशियो तो सोडियम और क्लोरीन का 1:1 ही रहेगा. कोऑर्डिनेशन नंबर में हम एग्जैक्ट नंबर स्पेसिफाई करेंगे. हर एक सोडियम कितने क्लोरीन से सराउंडेड है, हर एक क्लोरीन उस लैटिस में कितने सोडियम से सराउंडेड है. ये 6:6 is a way of writing the coordination number, the conventional way. It is not a ratio. ठीक है. So lattice energy is also defined as the energy released during formation of a lattice. Na plus gaseous combines with Cl minus gaseous, forming NaCl solid. In this process, some energy is released. The value will be delta H Le will be negative. Yes. So whether we are defining lattice energy in terms of breaking of a lattice or formation of a lattice, its value may be positive or may be negative. The magnitude will remain same. Okay? The magnitude of lattice energy will be in terms of formation of a lattice, delta H Le will have a negative value. In terms of breaking of a lattice, delta H Le will have a positive value. ठीक है, आ रहा समझ में? Lattice energy is a measure of the attraction between the cations and anions. Stronger is the attraction between cations and anions, more will be the lattice energy. ठीक है? In a way, it is a measure of strength of ionic bond. Stronger the ionic bond, more will be the lattice energy. You can say that lattice energy is a measure of the strength of ionic bond. Stronger is the ionic bond, more is the lattice energy. Now we'll do factors affecting lattice energy. We see that lattice energy is proportional to the magnitude of charge on the cation and the magnitude of charge on the anion. Z plus is the cationic charge, Z minus is the anionic charge. Lattice energy is also inversely proportional to the interionic distance. R plus is radius of cation, R minus is radius of anion. And R plus plus R minus is the interionic distance. More is the distance, less will be the attraction, less will be the lattice energy. Smaller is the distance, more will be the attraction, more will be the lattice energy. Normally, we compare lattice energy by first two factors only. Charge and size only. But there is one more factor. ये वाला फैक्टर क्या हो गया? फर्स्ट फैक्टर इज चार्ज, सेकंड फैक्टर रेडियस मतलब साइज. तो हम जनरली चार्ज और साइज से ही कंपेयर करते हैं. बट एक और फैक्टर है, कुछ कुछ केसेस में हम वो वाला फैक्टर भी यूज करेंगे. ये जल्दी से नोट कर लो. नेक्स्ट देखो, नेक्स्ट नेक्स्ट देखो. Third factor of lattice energy. Lattice energy is proportional to coordination number. Okay. Generally, coordination number is high when cations and anions have similar size. For now, we'll not be able to understand this. We'll study the calculations of coordination number in a chapter called as solid state. But अभी के लिए बस इतना लिखो कि coordination number is high when cations and anions are of similar size. Okay. This factor in particular is important for carbonates and sulfates of group 2. Group 2 carbonates, group 2 sulfates, beryllium carbonate, magnesium carbonate, calcium carbonate, calcium carbonate, barium carbonate. The order of lattice energy is the lattice energy increases. Same is true for sulfates also. Beryllium sulfate, magnesium sulfate, calcium sulfate, calcium sulfate, barium sulfate. We say that carbonate ions, sulfate ions are large ions. Therefore, as size of cation increases down the group, coordination number increases and hence lattice energy increases. ठीक है? अभी के लिए इन दो एग्जांपल्स को छोड़ के बाकी सारे एग्जांपल्स में विल कंपेयर बाय चार्ज इन साइज. कुछ और एग्जांपल्स देखो. Compare lattice energy. We'll do some more examples. Let us compare between NAF, NaCl, NaBr, and NaI. Cations in anion different. As the size of anion increases, lattice energy will decrease. Lattice energy is inversely proportional to size. The size of anion increases, lattice energy decreases. ठीक है? और एग्जांपल देखो. सोडियम क्लोराइड, पोटेशियम क्लोराइड, रुबिडियम क्लोराइड, cesium chloride. Same logic यहाँ पे भी अप्लाई करेंगे. Size of cation increases, lattice energy decreases. So lattice energy is inversely proportional to size. It also depends on charge. Suppose sodium chloride, sodium oxide, and sodium nitride. इनमें lattice energies compare करेंगे. Charge देखो क्या है? Sodium chloride, chlorine is -1, oxygen is -2, nitrogen is -2. As the charge increases, lattice energy will increase. As the magnitude of charge increases, lattice energy increases. ठीक है? Clear है ये? समझा? ठीक है, आज के लिए हम इतना ही करते हैं. केमिकल बॉन्डिंग में भी कुछ होमवर्क नहीं दे रहा हूँ. कंप्लीट द पीरियोडिक टेबल बुकलेट. ठीक है, पीरियोडिक टेबल का बुकलेट कंप्लीट करो. नेक्स्ट क्लास के बाद में केमिकल बॉन्डिंग में होमवर्क दूंगा. ठीक है, क्लियर है सबको ये? Yeah, I will send a recording. Sorry, I couldn't share it. I will share it right now. Chalo, thank you everyone. Ending the lecture. Have a good day.